Hello everyone. So if you remember in our previous class we done the troubleshooting static dynamic 802.1q trunking protocol. We done what is this one and how we can configure. After that we done 4 troubleshooting lab for this one. So this one is finished. Now we will go for STP. After that we are going to do the ether channel. If we do ether channel directly, maybe you will have some confusion why we are using ether channel. So first we will learn the STP, what problem we will have by using STP, then how we can overcome by using ether channel, we will check that one. So here what they mention here, configure, verify common spanning tree, and in that one they mention RSTP and MST. So these two things we need to do. But anyhow we will discuss some basic theory about the STP, what is STP, why we need, and some property about STP. After that we will discuss RSTP, MSTP. So let me show you here. First thing, STP is a protocol. We learn STP in our CCNA level also, but we don't have MSTP in the CCNA. We have in the CCNA RSTP, port fast, STP we have in the CCNA. But MST we don't have in CCNA. In CCNP we will discuss that one also. But before going to that one, we will discuss STP. STP stands for Spanning Tree Protocol. The full form for STP is Spanning Tree Protocol. And why we are using STP? Example, let me take my blackboard. Example here, if you see, we have, imagine I have 3 switch. Okay, I have 3 switch. I have one switch here, this is a switch 1. I have another switch, that is a switch 2. I have one switch here, that is a switch 3. Okay, so now I am having 3 switch. It is connected, and when we connect the switch, whenever we have loop in the network, this is creating the loop. How we can say this is creating the loop? Because if you see, if any frame is going, it will go like this, and it will go like this, it will go like this, it will go like this. So same frame, if this guy, one PC from here sending any frame, PC1, if PC1 is sending any frame or any data to the PC2, this will go here, this switch will receive, he will forward, and same it will forward to all the ports. So this traffic will rotate, because in the router, when we are discussing with the router, we have TTL value. So when the TTL value expire, that packet will be destroyed. But here in the layer 2 technology, we don't have the concept of TTL value. So here packet will not destroy. That is, frame will not destroy. It will go around and around. It will go around and around the switch. To overcome these types of issue, we are using the STP. STP, how we can define STP, that is spanning tree. First of all we need to say STP stands for Spanning Tree Protocol, and then what we can say, STP is a layer 2 protocol which is used to avoid loop in the network. Spanning Tree Protocol is a protocol which is used to avoid the loop in the layer 2 network. Layer 2 means we are connected the switches in our LAN area, and if we have anywhere loop, it will disable that link, it will block that link. How we are having loop and how it is disabling, we will see here in the packet tracer. If I show you in the packet tracer, easily you will understand. So if you see here what we have, I have 3 switch. Just now what I draw here, I have switch 1, this is switch 2, I have another switch 3. I connected 3 switch with the Ethernet cable. I connected, it is creating loop. How we are saying it is creating loop? Because if anything go here, it will come here, it will go here, it will creating loop. It will what we can say, our traffic, our data will be rotate around the switch. So it is creating the loop. That's why one port will go down. If you see in this scenario, this port is off, this is in the disable mode, means it is not working. We can say it is switch off, it is not working. It is working green. In the packet tracer we can see as a green, but in the real scenario you will see that one, this is block. How we know block? We can check. We can go inside the switch and we can type show spanning tree protocol, show spanning tree VLAN 1. When we type this command, we will get the status of this switch. So what we are saying, first of all, STP. STP stands for spanning tree protocol. Why we are using this protocol? To remove the loop from the layer 2 network. Here it is creating the loop, so automatically STP will block this one link depending upon some algorithm. They are going to run the algorithm and they are going to block one link. So what is algorithm, how it is blocking, we are going to check that one, each and everything one by one. One by one we are going to check that one. So now if I take one another switch, let me show you. I will take one switch here, I will take one more switch, I will take one cable here. Imagine I will connect one cable here. Okay, this is one cable. It will take some time, after that it will become green. Why they are taking time means here spanning tree is working, STP is working here. They will do election and they will check do we have loop in the network. After that it will be green. That's why it is taking the time. They will take 30 seconds, 15 seconds for listening, 15 seconds for learning. We are going to see this one, we are going to learn in detail. Now just remember, whenever we plug the cable, they will take 30 seconds to start working, to start forwarding of the traffic. So now if you see it is green, after 30 seconds it become green. Example, if I take one more link here, if I connect one more link here, now if you see we will have here uplink is green. Let me remove the port name so you can easily see that one. So if you see here what we have here, this link is working fine. Here we have green, this is working, and this one just now we connected, so still spanning tree is working here. They will check and they are going to block one. Why they are going to block? Because it is creating the loop in the network. If the frame will go, it will come again here. That's why they will block one interface. And if you check here, they block this one. So traffic will go from here like this way, but it will not come back again here. So we will not have the loop in the network. So that's why we have the spanning tree protocol. And how we can check the spanning tree protocol? We can go inside the switch and we can write here show spanning tree, press enter. If you want to check for which VLAN you want to check, you can write that VLAN number also. Example, by default we have VLAN 1. I am writing show spanning tree VLAN 1. Okay, if you have more than one VLAN, then you can write directly show spanning tree and press enter. You will have the detail. Or particularly if you want to check particular that VLAN, then you can write show spanning tree and that VLAN number. So what we are getting here, I am here in the switch 1. When I type here show spanning tree, this one, it is showing us we have the VLAN 1. This is the detail for the VLAN 1. From here to here, this is a detail for VLAN 1. And what we have here, here we have spanning tree enable protocol IEEE, it is enable. And here we are having some detail about the root ID and some detail for the bridge ID. And what detail we have? We have priority, we have MAC address, we have cost, we have port, we have hello timer, maximum age, forward delay. Same information we have here also. We are going to discuss each and everything in detail. Now just I am giving you overview. So what I am saying, let me repeat again. I am saying when we type show spanning tree, we are getting detail about the spanning tree. Now we have only one VLAN, that is VLAN 1. So we are getting the detail of VLAN 1. What detail we will get? First of all, which spanning tree is working here. IEEE means normal spanning tree, that is a standard. STP is working here. Spanning tree enable protocol IEEE. Then we have the detail of the root ID and the bridge ID. What is root ID? What is bridge ID? We will discuss now. After some time we will discuss. After that we have the priority, and why we are getting this priority we are going to see that one also. And we have the address, this is a MAC address, and we have the cost, port, hello timer, maximum age, forward delay. Same information we have here for the bridge ID. And after that we have the interface, whatever interface is present here, and we have the role of that interface. Like this interface is root, this interface is alternate, and this interface is forwarding. FWD means forwarding. Forward, they are in the forward mode, they are forwarding the traffic. This interface fast Ethernet 0 by 2 is in block state. If we want to verify, we can verify also here. Let me show you. If you see here F0 by 2, and where we are in the switch 1, this is a F0 by 2. If you want, I will enable the port here. How we will enable? We need to go in the option, preference, and then always show the port. Then we will have the port number. So if you see here, this port is block. We are saying port is block, and we can verify here. When we go inside the switch and when we are typing show spanning tree protocol, show spanning tree VLAN 1 or only show spanning tree, we will get the detail. And here if you see, this is a fast Ethernet 0 by 2, it is block. And we have the cause here. We are going to see why we are getting 19 only. So now what we are understanding, we have the interface, we have the role, and we have the status, we have the cause, we have the priority of that one, and then we have the port number. This is a F0 by 1, that is a port 1, and this is a F0 by 2, that is a port 2, and they are connected as a point to point. So this detail we are getting. This detail we are getting inside the switch. So generally when we connected the switch, when we connected the switch with the cable, and when we are creating the loop in the network, or imagine you have two switch like this. When we connect cable to two switch together, one switch will become as a king switch. One switch become as a king switch, or we can say root bridge. Why we are calling bridge means this technology developed at the time of bridge, when we are using the bridge that time. After that, bridge upgraded to switch and we are using the switch, but the technology they introduced at the time of the bridge, so we are calling the bridge only. So bridge is nothing but, imagine, switch only here in our case here. So what we are saying, whenever we connected the switches, one switch will become as a king switch, or we can say root bridge. One switch will be the main switch. So all traffic need to go through that switch only. So we will see that one. And the guy who become as a king, his port will be in the forward, means it is always green, working. That port will be working. Even if it is creating loop, he will not block the port for the king switch. They will block for the other switch. Imagine if you have any VIP in your country, the VIP road always open. Whenever VIP is going, they will not close any route for the VIP, but it will be closed for the normal guys. So same thing, wherever we have the king switch, his port always in the forward, it will not close. So how we will have the king? How this guy only king? Why not this guy become as a king? Maybe you will have the question. If we take here in this scenario, I have switch 1, switch 2, switch 3. We have 3 switches here. And here one guy will become as a king. As per our theory, what we are saying, whenever we connected switch with the cable, and one guy will become as a king and remaining guy will be non-king. And king is also known as root bridge. We can say king other name is root bridge. So one guy will become as a root bridge. Whoever become root bridge, his port will be in the forwarding state, that is he will forward the traffic. He will not block his port. And what we can say other thing, we are saying why we have only this guy as a king. Maybe by seeing the port we can say this guy may be king or this guy may be king, because his interface is in the forward. This interface is down, so this guy will not be king. Let me repeat again. We are saying in the spanning tree protocol, one switch become as a king switch and his port will be always in the forward state. It will not block. So by seeing this topology, we can say maybe this guy as a king or maybe this guy will be king because they port are green. But this guy will not king because these port are not green. It is in the block state. This one is block state. So how we will know which one is king and what algorithm they are running? They are using the STA algorithm, spanning tree algorithm, to select the king. How they are selecting? one switch as a king. Maybe you can say why this switch not become as a king, this one, why only this switch is king or why this switch is king. We have one algorithm. First thing, they will check the priority. First thing, when they are selecting as a king, they will do election. They will do election. So in election, they will check the priority of the switch. What they will do, they will check the priority of the switch. By default, all the priority of the Cisco switch is same. If you want, I will show you here. If you see, this is a priority. Okay, this is a priority. 32769, this is a priority. So I will paste here, this is a priority of this switch. If you check same thing in other switch also, we will have the same number. By default, all Cisco switch is having the same priority. Let me show you here also. If we go here and we write show spanning tree VLAN 1, because now we are doing for VLAN 1, and if you see, this is the priority for the root bridge. This will remain same for all the bridge, this one. In all switch, we are having the information of root, that is king information, and the bridge ID. Bridge means this switch. This switch is a bridge and this one is a king. This will remain same in all the switch. And how you know which switch is a king switch? You can see here it is written this bridge is a root, means this is a king switch. This is a king switch. And if you want to verify, you can verify this MAC address and this MAC address will remain same. Then we can say king switch. But now we will see how we are saying this guy is becoming as a king. So what they will do, they will first check the priority. Okay, they will first check the priority. By default, all Cisco switch is having 32769 priority. 32769 priority. So now we have here all switches having the same priority. Then what they will do, first they will check whoever is having the low priority, they will select that as a king. But all switches having the same priority. After that, they will look the MAC address of the switch. Whose MAC address is low, that guy will become as a king. If you see this MAC address, this MAC address, this MAC address, which MAC address is low? Here if you see B, if you see last 4 digit B is in hexadecimal. As we know, A is equal to 10, B is equal to 11. So here is in the place of B we have 11. If you see here we have 7. If you see here 7621. If you see here what we have 0498. But if you go for other number here we have E here. If you compare this number also 00E, A, B, C, D, E, 10, 11, 12, 13, 14, means here you have 14, 0, 0, 14, 0, and here if you see you have 0, 0, 0 and C means 12. So this number is big. Okay, this number is big. First we check this number is big. Why this is big? Because here we have the B means 11, means here we have 7. So if we compare, this is big, so this one is removed from our picture. Now we have these two. If we compare here, this one is 0012, but here is 00140. So this number is big, so this will remove. So this guy will become as a king switch. So what we are saying, how the guy will become as a king? Priority plus MAC address. Priority plus MAC address. By default, all Cisco switch is having 32769. This is a priority by default. This switch is also having same priority. This switch is also having same priority. This switch is also having same priority. Whoever having the low priority, that guy is going to become as a king switch. But here priority is having, all the guys is having same priority. So then we will look for the MAC address. Whoever is having the low MAC address, that guy is going to become as a king switch. If you see here, I copy and I paste the MAC address here. How we can verify MAC address? We can go inside the switch and we can write here, example, show spanning tree VLAN 1, or if you want to check for all VLAN, just we will write the VLAN 1. Okay, if you want to check for all VLAN, we will write just show spanning tree. But now we have only one VLAN, so we are getting information for one VLAN. And if you see this all information whatever is available here from here to here, this all information belongs to bridge. This is root ID. That means the king switch. This information all for the root bridge. So this is the MAC address for the root bridge, and this is a priority for the root bridge. If we check for the bridge ID means the switch where we are looking. This is a switch 1. This information is here, bridge ID. So this is the priority, that is 3276. Actually what we have, maybe you will say, you are saying the priority is this one, but here is written is this 3278. So see here, actual priority is 32768. But we are checking for which VLAN, that number will add here. We are checking for VLAN 1, so it will add here +1. So we will have 32769. This one. If you see here, this is a priority. They are saying system ID extend. That is nothing but VLAN number. If we check for VLAN 10, you will have 10 here. So in this number we will add 10 here. So this will change. This will change to 3267110. Just we are adding 10 here. This is 8 and this is 7. Here we will write 32778. This number. It will change that number. Just remember, you need to remember this number, and whatever VLAN you are looking, that number will add in this number, and that will come here. So this is a priority. Here also we will have that number. So by default all switches having same priority, so we will not look this one. This is a MAC address of the king switch. This is a MAC address of that guy. So whose MAC address is low, that guy is going to become as a king switch. If you have confusion, let me show you in the packet tracer, this GNS. I taken 3 switch here also. I connected here. I power on this. I put the MAC address. How I know MAC address? Just I go here in the switch 1. I type here show spanning tree. Okay. If you see what I done here, I type here show spanning tree. So when I type show spanning tree here, I get this information. This is for the king switch, and remaining this information is for this switch 1. So if you see here we are getting this is a root bridge, means this switch 1 is a king. So this guy is a king. Priority we have 32769 because we are looking for VLAN 1, and if you see here also priority, both guys are having the same priority. And if you check, this is a MAC address, this is a MAC address, both guys having same MAC address. Why we are getting same? Because this is only the king. This information remains same in all the switches, and this information is this switch information only. So what I done, I copy this MAC address, I paste here for the switch 1. Then we check in the switch 2 also. When we go in the switch 2, I run show spanning tree here also, and then we get this information from here to here for king information. And if you see here, we don't have here anything written like this is a root bridge, as we are getting here this one, but here we don't have anything, that one. And this is a bridge ID information, that is a switch to information. What information we have here? This is a MAC address. So I am taking this MAC address. I will keep that MAC address here. Then I will go to the switch 3. I will run same command show spanning tree. If you see here, we are getting the spanning tree enable, and here is the king information, and this is the, here we don't have anything written as a, this guy as a king. So what we can say, this is separate guy, this is separate, and this is a bridge ID. Bridge ID means the switch 3 only. And here this is a MAC address. I paste the MAC address here, and now you can compare MAC address here. Easily you can compare. Maybe in that scenario we have different, so it is little complex. Here if you see AABB-CC00, this is common for all the switch. Okay. So what we can say, first we check the priority. All guys is having same priority. So this one, all guys is having same priority. So we will not look this one. We will leave. We will go for MAC. And this 2 from here to here is same MAC for everyone. After that we can see we have here 300, here 200, here 100. Who is having less? This guy is having less. That's why this guy become as a king. If you see here, this guy, the switch 1 become as a king switch. This is a root bridge. So what we will have, king switch port will always in the forwarding state, means it will always in the forwarding state. means it will not block. We are calling that one as a designated port. So just remember, designated port is nothing but king switch port, and we can have non-king switch also have the designated port. Means this port will be in the forwarding state. We are calling designated port name as a designated port, and that port always in the forwarding state, and king is having that one. Opposite to king, whoever is connected, that is a root port. If you see this guy is opposite to king, so this port for this switch, this port will call as a root port, and this port also in the forwarding state. This is also going to be a forwarding state. Other than this one, here one port will become down, one port will be working depending upon the cause. We are going to check that one. So this is a concept of the spanning tree. Now we will discuss the theory. We did not discuss theory, just we go for the basic lab. So now we will discuss spanning tree. We know already it is a full form of the spanning tree. We know STP is nothing but spanning tree protocol, and already we told this one is used to remove the loop from the layer 2 network. Whenever we are having the loop, spanning tree is helping us to remove the loop in the network. Automatically he is going to block one interface, so we will not have the loop in the network. And it is a open standard. It will work in all vendors, not only the Cisco, Juniper, Hawaii, any vendor, it will be work in all the switches. After that, what we will say, STP will work when we connect the multiple switch by using redundancy link. Redundancy means like when we are connecting two link. Why we connect two link? Example, I will say I will connect one link, I will connect one more link. I will say I have the redundancy here. Example, if this port go down, our data will be going, it is working. Why it is working? We have one other link. So we have two link. If even one link go down, our network will not down, it will be up with the other link. That is nothing but redundancy link. We can say redundant link is nothing but applying more than one. So whenever we connected more than one link, we will have this issue. What issue we will have? It will create the loop in the network. It will create the loop in the network, like I have switch 1 here, I have switch 2 here, and I connected with the redundant link. Example, I taken 2 link. So if any frame is coming here, that will go here, and same frame will come back to this switch. Again it will go here, it will come back like this. It will rotate, it will create the loop in the network. To avoid this one port will be down. And first they will do the election. They will be make one guy as a king, and king port will be always in the forwarding. Other than king, one port will be blocked. Which port will be blocked? Why it will be blocked? We are going to discuss that one. So till now we discuss here, and by default in the Cisco switch it is enabled. STP is enabled by default in the Cisco switch. No need to go and do anything in the switch. Automatically it will enable in the brand new switch. And STP will help us to create a loop free topology by blocking certain interface, as we discussed just now. Whenever we connect the multiple link, we will have this one. Automatically he is going to shut down that one port of the redundant link. How they are finding there is a issue and there is a loop in our network? They are going to use one algorithm. With that one they are going to calculate, they are going to estimate which port and where it is having the loop in the network. They are going to use one algorithm to check that one. That algorithm name is known as spanning tree algorithm. Spanning tree algorithm. What we can say, we use STP to avoid the loop to loop. In the layer 2 we have the loop. To stop this one we are using the spanning tree algorithm. STP is using that algorithm to stop the loop. And what we can say, spanning tree are using the BPDU. This is important also. In interview there you will get this question also. So what is BPDU? That is, BPDU stands for Bridge Protocol Data Unit. BPDU stands for Bridge Protocol Data Unit. In every 2 seconds, the switch will send the BPDU. Switch will send BPDU to another switch. We will check that one. This switch will send the BPDU to another switch. This switch will send the BPDU to another switch every 2 seconds to prevent the loop in our network. So what we are saying, now what we learn one new term saying that BPDU. BPDO we are saying all the switches are sending the BPDO to avoid the loop in the network. In the BPDO we have the different information that we are going to check. So this is one topology as we design here in GNS3, same like this. We are using here multi-layer switch, but this switch is working as a layer 2 because we did not enable IP routing here. So this is like a layer 2 switch. When we connected, one port is blocked here, and if we don't have the STP, we will have the issue. First issue, we will have the broadcast storm. Second issue, we will have the MAC database instability. Third issue, we have the multiple frame transmission. So these are the three issues we will face if we disable the STP in the production network. So if in interview, if you get the question what issue we will face if we disable the STP in the network, you can tell that one we will have the broadcast storm. Broadcast storm means like if you have one machine here, okay, this is a PC1 and this is a PC2. If this guy is sending something, it will go here, it will come here, it will rotate and it will create the storm here, broadcast storm. That is known as broadcast storm. So with this one our network performance will go down. And MAC database instability means here when we are checking the MAC database, example like but here we did not connect anything, but anyhow we will connect some PC. When we check the show MAC address table, now we have the address here because we connected this interface, so we are getting this interface address here, this MAC address of this interface, particular interface. So like this we will have the MAC table entry we have. What entry we have? What is connected to that interface. So this will become as a unstable. Sometime this entry will come to this interface, sometime this entry will come to another interface, the same entry will come here. Why? Because it is rotating around the switch. Rope is creating the same frame will go here. When this switch receive the frame, he will say okay it is coming from here, but same frame will get here, so that guy will think it is coming from this switch. So they will change the entry in the MAC table. So we can say we have the issue MAC table instability, and we will have multiple frame transmission. Multiple frame transmission means more frame is going here. So same thing, one we will have broadcast storm means frame will rotate. It will go here, it will come here, it will go here, it will come here, like this. And second thing, database, that is MAC table instability. MAC database instability means in the MAC record it will change, suddenly it will change. We will check that one. And multiple frame we will have. So we can use one topology like this to verify that one. If we disable STP, what issue we will have, we can verify that one. So if you see here in the packet tracer, we have here, right, 3 switch already we have here. So what I will do, I will take one PC here, I will take one PC here, I will take one PC here, and I will connect this PC to this switch. I will connect here and I will connect here, I will connect here, and we will assign some IP. Let me write here label 192.168.1.1. I will write 1.1. I will assign this in the PC1. Just this is the basic, just I am assigning the IP, and I will assign here also some IP. I will write here 1.2. okay, this is a 1.2. I will assign here also the, what I can say, IP here. Okay, then I will go to this PC also. I will assign here IP as a 1.3. I will put this IP in my machine. I will go here, I will put this in our machine. And if you want, I can change the MAC address also. We can go here in the configuration, physical, in the configuration, and this one, fast Ethernet, in this location, and I will change here the MAC address. In real scenario we cannot change, here in the lab we will change. I will write here a dot 4 time a dot, I will give simple MAC address, so easily we can track this belongs to which PC, b 4 time, and then I will put here 1111. okay, imagine this is a PC1. I will give this MAC address for the PC1. Just I am changing the MAC address here. Let me check MAC address change here. Yes, so this is a MAC address. I will paste here, so we know this is a MAC address we have in this machine. So just I change the MAC address of this machine. and here let me change the MAC address of this machine. How we will change? Go in the configuration, go to the fast Ethernet, and here I will change, instead of 111 I will write here 2.2.2.2 4 time. So what we will have here, we will have the idea this is a PC2 and we have this MAC address from the PC2. I will paste here, and here for this machine what I will do, we will put here as a 3-4 time. So let me write as a 3-3-3-3 4 time, and I will copy this MAC address, I will paste inside the machine. I will change the original MAC address here. If you see here, I will go here, I will paste this MAC address here. Okay, now we can check MAC address here. First of all, let me check here, enable show IP, show MAC address table. If you see, we have some old MAC address, some new MAC address, just now I take. So let me clear, first of all I will clear MAC address table. So now I will delete the MAC address. Now I will write show MAC address table. So still it is not deleted. Let me clear MAC address table. Now let me check it is erased or not. Yeah, now it is erased from the switch 2. So let me do for the same thing for other switch. So I am removing the entry, so we can check the issue like MAC database table is in instability, we can verify that one. So I will write here let me clear also, clear MAC address table. Let me check I have the MAC table here or not. Here I have MAC, still it is not clear, maybe they learn. So I will clear MAC address table, show MAC address table. Still we have, this will clear when we type this command, but I don't know, maybe here we have some issue, maybe sometime we need to restart the packet tracer. Anyhow, let me clear again, and then we will check show MAC address table. This guy is not going. Let me save this and reload the switch. Okay, till this switch reload we will go for the switch 1. Here we will check, I will check show MAC address table. So we have here, I will say clear MAC address table, and we will write show MAC address table. Still it is not clear, MAC address table. And now if we check, I don't know, some issue with this one. By writing this command it will clear, it should clear. Let me reload. Why I am reloading? I want to remove the old MAC address because now we are using this one. So we need to see AAABBB11 for this. 1.1 will have the 111 and 1.2 will have 222. 1.3 will have this one. Like this way we need to check. So I reboot the switch. I will do fast forward. If we do fast forward also it will remove. But anyhow, let's see now we have or not. If you see here, I will write show MAC address table. Now we have they taken old MAC address. The new which we give is still it is not taken. If we check here, did we change that one or no? Configuration here is, we have new MAC here. Okay, let me do fast forward. Okay, let me send some traffic also. I will send one traffic from here to here. It is gone, and let's see the entry we have in the MAC table. Yeah, we have the entry. So let me ping all the PC. So we will have the entry in our MAC table. After that we will check the MAC table instability. Let me put here, this guy is having some issue, or we assign IP here or we forget. We did not assign IP, that's why we are not getting this MAC table. Let me put the IP here 192.168.1.2, and here let me check here, did we assign here IP or not? We assign here IP. So let me send some traffic. How we will send? Just click here, click here, click here. it will say successful here. Or if you want to see here in the simulation, we can click the simulation and then we will click. And if you see, I will send one packet from here to here. This one is coming here, successfully come here, and if you want I can play here. It will go from here, it will go from here to here. You can play and we can check also. It is going, it is coming. So we will have the MAC entry in our machine. That's why I am sending the traffic. If I want to send from here to here also, just I am pinging this one. I can ping also, I can send the traffic also. Now I send the traffic, so our MAC table will have the entry. Okay, so now we can check here. If we go here, if we type here show MAC address table, we have the entry. Every 5 minutes they are going to erase the entry, every 300 seconds. As we discussed in our previous class when we are doing the MAC table lab, we learned that time that every 5 minutes switch is going to remove the MAC entry. So now what I am saying here, in this one, if you see, this is a fast Ethernet 0x1. Okay, fast Ethernet 0x1, we have this entry here in this interface. Fast Ethernet 0x1 is having the entry 3.3.3. But after some time, this MAC address will move to any other MAC address if we are disabling the STP. That issue we will face. So let's go and disable, but don't disable in the real scenario. In the production network, don't disable the STP, else we will have the issue. Now I will disable in all the switches. Now it is working, that's why this port is blocked. What I will do now, I will go here, I want to disable. How we will disable? We will go here in the config tree, we will write no spanning tree VLAN 1. I am saying I don't want to run the spanning tree for the VLAN 1. I will take this, I will copy this one, I put in the switch 2. So switch 2 is going to disable that one. Now I will go for the switch 1. I will do for the switch 1 also. I will say no spanning tree VLAN 1. So this switch also disable. And if I go here in this switch also, I will write no. Let me write here also. If we have like this, we can do fast forward, so it will go. Let me go here. I will write here enable. Then I will go in the global configuration, no spanning tree VLAN 1. So now I disable the spanning tree. After that, if you want to check, we can check also. We will write show spanning tree VLAN 1. If you see no spanning tree running, no spanning tree instant exist. Here we don't have any spanning tree. And if you see here, no port block here, nothing is blocked here. Okay, but now we will have the problem. If we send one packet from here to here, we will have the issue. Let me open the simulation mode here and we will check there. We will check there. What I will do, I will send some traffic. I will play here. If you see, same packet is going in multiple places. We are sending only one place, but see, it is going here and here. It is revolving around and around the switch. If you see, these packets are revolving around the switch. So this is creating the broadcast storm. It is going here and here only. Let me play again so you can see what happening. It is revolving around and around. It is going around and around the switch. It is creating the broadcast storm. Now I generated traffic from only one PC. Imagine if you are having 300 switches, maybe you are having 500 PC in your organization. How big broadcast you will have in the switch if you disable the spanning tree. That's why what we are saying, we should not disable the spanning tree. Spanning tree is a protocol which is used to avoid the loop in the network. Now we have the loop. If you see, same packets is coming from here and here. If you go here in the MAC address table also, if we check here, we will write show MAC address table. If you see here, imagine this is a fast Ethernet 0x1, you have 3.3. Okay, and if you see same Ethernet, fast Ethernet 0x1, you have the entry 1x1. And if you see fast Ethernet 0x0, you have another entry. So same MAC address, same entry, same interface, he is showing the double time entry. And if we do here like this, it will change also. So MAC address table is unstable. It is changing, it is not stable. If you check again after this time, you will have the different MAC address entry here. If you see, just now we have 3.3 for the 0.1. You can observe here, just now what we have, this MAC address the switch is saying What switch is saying? A dot A dot A dot B dot B dot B dot 3.3 is connected to my fast Ethernet 0/1. This switch, the switch 1, this is a switch 2 is saying for my interface this one I have this MAC address. But now suddenly he is saying this MAC address is connected to my interface fast Ethernet 0/2. So MAC, what we can say, MAC database table is unstable. Switch is getting confused. He is saying just now I received one frame. In that frame I have the MAC address. I learned that MAC address from this interface. So I store in my database saying that I have this MAC address is connected to my this interface. But suddenly after some time, same frame I am getting from this side. So I am saying that I have this MAC address is connected to this interface. So switch is confused. He is saying after 2 seconds it is coming from here, again after 2 seconds it is coming from here, sometime from here, sometime here, from here. The MAC table, that is MAC database, is unstable. So first problem we have broadcast storm. Second problem we have MAC address instability. Third problem we have the multiple frame, as we saw here. So what we can say, if anyone asks you in interview, if we disable the spanning tree, what issue we will have? We will have the broadcast storm like this. And second thing, we will have MAC database instability here. MAC database instability here. After that, what we will have? One more thing, we have multiple frame. Our data will not go. It will revolve around and around. At last, it will crash our network. Sometime our packet tracer also crash and it will close if we run more traffic in this loop network. So in the production network, don't disable the STP. But here in the lab purpose, we can disable. Let me save here, because if we did not save, sometime we will have issue and packet tracer will crash also. So I generated here example. I will generate from here to here. I will generate from here to here, and I will generate from here to here. So many traffic I will generate, and if you see how many packets, how many thing we will have here. Let me move here this one. Maybe some issue here. Maybe the network go down when we block here. Let me generate some more traffic from here to here. Now already it is blocked. Let me show you. And if you see here, we can check the physical view also. If we go in the physical view, I will show you here. If you see here, let me make zoom in. If you see here, this is a simulation and this one is the real. This is a port. If you see here, it is blinking, but now it is having some issue. It is not blinking, but you will have all this port green color will blink very fast. Maybe in the, if I remove from the simulation, it will blink very fast, this one. Let me move from the logical. Let me remove this one. Maybe it is creating problem, this one. So when we done this one, let me go to this and play this one. Here, if you see here, it is fail because it is block our network. This broadcast frame here, if you see here, it is giving fail. That's why it is not working. And here also, if we go here, this green light will blink very fast, but now it is not showing that one. This green light will blink very fast, like it is crash. So what we will say, we will have issue. Our packets will not go to the destination. Our packets will not go to the destination when we enable the STP. So we will not when we disable the STP. So this is the problem we will face if we don't have the STP. First problem, as we told, we will have the broadcast storm. We checked just now, and we told the MAC address table instability. We verify that one also. Same port is having the different MAC address. Switch is confused themselves, and we have the multiple frame transmission. So this is a problem we will have if we remove the STP. So now I will enable the STP. How we will enable? I will go in the global configuration mode. I will write spanning tree VLAN 1. Okay, so it is enabled now in this switch. I will write here spanning tree VLAN 1. It is enabled in this switch also. Now I will go to the other switch. I will enable here also spanning tree. If we have like this, we can do fast forward and then we can go here. I will go in the global configuration mode. I will write spanning tree VLAN 1. Now it will enable. The spanning tree will be enabled after some time. And if we check here, we will have the spanning tree. If we write here show spanning tree, now we have the spanning tree. So what we learn here? We learn here how we can disable, but in the production network don't disable that one, and we verify what issue we will have if we disable that one. So this theory we discussed just now from here to here, and after that we will discuss the priority. So before that one, let me check the